Good evening, sir.
Hello. Hello. Am I audible?
Yes.
Okay. So, good evening to everyone. So, very less people have joined. Is there any another session going on, or it's
Sir, your voice is too low, sir.
now is it okay?
Yes, sir.
Yes.
Yes, sir. Now it's okay.
Okay. Okay. Great. 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 Okay. So, meanwhile, how many of you have covered the lectures video of week 11 and week 12?
Yes, sir, covered, sir. But in doubt in the poison distribution of week 11.
Okay. No problem. No problem. I think in last session, Mayur sir has covered till hypergeometric, and also today we'll start from the poison, and then we'll move
Yes,
to the
sir.
concepts of week 12, like uniform, exponential, and all right. I think in week 12 there is only two distribution, uniform and exponential, if I'm not wrong, right?
Yes, sir. Uniform and exponential.
Okay, no problem. We'll discuss the first concept, like Poisson, and I will tell you some example, or I will take some example from activity itself, and then we'll move to the next one. Okay. Okay. And did you go through that solve the PDS which we have shared already on the portal? Because there are some questions related
Yes,
to
sir.
it. So if
Sir, you
you
also tell a doubt, sir. I have to doubt in week 11, sir.
okay, no problem. So what we'll do, we'll start the I will see. I will first cover the concepts of, like, see, poison has been left in the last session, right? So I will discuss the poison. Then I will discuss the some concepts of week 12, like uniform distribution, exponential distribution, along with some example. After that, we'll take the rest of the doubt. Okay.
Sir, can you note my two doubts, sir?
Yeah, I will take the doubt. What is your doubt? Which distribution
Sir,
it's?
11.8, question number second, and practice assignment, question number 11.
No problem. What I can do. So it's from Poisson distribution, right?
Sir, I want to know because, sir, I joined the sir, math section, sir. So you take, then I see the recording video, sir.
Uh, okay, okay. So someone of you can note down that. I will tell you at the end of this. No, okay. And one more thing. So I think 11 point is concepts of Poisson distribution, correct? So let me start the concept of Poisson distribution. I will tell you in which scenario we have to use and all, and I will take that out. Okay. Okay, it's clear. So Prayas, what you can do, just write down in the chat box what is your exact doubt. Okay, yeah, please. So I will take the doubts, but just someone remind me at the end of this. Okay, I will take. Okay, so it's, I think math session is also going on. That reason very less people have joined. Hello.
Sir, I write my question on chatbot, sir.
Yeah, sure. We'll take. No problem. Hello, am I audible? Everybody?
Yes, sir.
Yes, sir.
Okay, so is there message is also going on?
No idea, sir.
Yes, sir, it is going on.
Yes, sir.
Math one, right?
Yes,
Yes,
sir.
sir, that's one.
When it started?
At 6 only, same time.
Why is this classing happening? Okay, no problem. Let's discuss the concept. Rest of the people can watch in the on the YouTube itself. Okay, so meanwhile, any one of you can tell me in which scenario you will prefer the Poisson distribution?
When you're dealing with queues.
Okay. Q of what?
Basically, you have a certain number of arrivals on a distributed length of time, which is continuous in nature. Basically, that's what it is.
So yeah, let me start. So Poisson distribution. See, there is different kind of scenarios for using binomial distribution and hypergeometry. Like say in binomial, number of trials should be fixed, right? And each trial should be independent, and probability of success is should be p for p, that p should be same for each trial, right? In that scenario, I'm going to use the binomial distribution, right? And each trial should have two outcomes, like because binomial is nothing but sum of some, let's say, an IIT Bernoulli random variable. So that Bernoulli random variable should have only two outcomes, either success or failure, right? So in which scenario I should prefer the Poisson distribution? So there is like suppose you are interested to find the what is the probability of a number of events occurring in a fixed interval of time or space. I will tell you what is the meaning of interval of a time or space. So basically, I will prefer the Poisson distribution, which I'm interested to let's say find the probability of probability of a number of events occurring in a fixed interval of time or event, right?
Yes.
So what is the meaning of fixed interval of time or space, basically?
Within
So
a
let's
fixed
say,
time.
sorry.
Carry on, please.
Yeah. So for example, suppose I'm interested to know, let's say, number of accidents, right? Happening on a, you can say, at a, on a road or in a particular day, something like that, if you are interested. Let's say, okay, so what about time? Time, let's say I'm interested to know number of, let's say number of suicides reported in a city, right? Reported in a particular city, that can be anything. So it's a space, right? Interval of space, kind of, or interval of space, you can say number of typos in a book, correct? Something like that, correct? Let's say, or you can say number of typos means you can say printing mistake and or anything else, that printing mistake like that, okay? Or you can say number of telephone calls received per minute at a call center. Number of you can say this should be telephone calls received per minute at a call center. Or what another can be? Another can be like number of vehicle passing through a traffic intersection in a fixed interval time of 1 minute or 10 minutes, something like that. So here, like say you are interested to know the number of telephone calls received per minute. So this is an interval of time. Here, interval of a space, like that. So in such kind of scenario, I'm interested. I will prefer the to use the Poisson distribution. So basically, if you have watched the lecture video, basically Poisson distribution is nothing but a limiting, Poisson distribution is nothing but a limiting case of binomial distribution, correct or not? So what is meaning of that limiting case? How I will get the Poisson distribution? This number of trials should be large and success probability should be small, and multiplication of these two, it's nothing but we are going to denote in this case as a lambda parameter, which should be the finite. Actually, there is one derivation behind it, so that's not required here. If you are interested, you can explore. But this Poisson distribution is nothing but a limiting case of binomial distribution. In binomial distribution, we have two parameters, right? N and P, correct? This is number of trials, and this is the probability of success. Correct? So basically, if you see what we are saying, this is and going to and it's tending to infinity, right? Tending to infinity means number of trials should be large. It should be large. And P is small, and value of product of N into P is will be lambda, which we are going to denote. We are going to say it's a rate parameter in case of this Poisson distribution. So suppose I'm saying, let's come to some that technical thing. Suppose X is a suppose I'm saying X is the X following Poisson distribution with parameter lambda. Then what is the PMF? First of all, this Poisson distribution is the discrete or continuous? It's a discrete, right?
Discrete.
Here I'm interested in the counting, correct? X is something we are interested to. Let's say if you see here, what is it? These all are counting, right? We are not going to measure number of suicide, you can count, number of printing mistake you can count, number of telephone calls you can count, right? So if I'm able to count the things and it is taking the distinct value, that means it's a discrete random variable, right? Are you getting me?
Yes.
So here X
Yes,
is your
sir.
random variable, which is let's say I'm saying it follows Poisson distribution with parameter lambda. So basically this lambda called rate parameter, on an average rate parameter. And what is the PMF for this? So PMF, suppose I'm saying X equal to small x, this random variable is taking value small x in nothing but e raised power minus lambda. Lambda is the parameter. Lambda raised power x divided by x factorial. First of all, tell me what will be the value of x?
0, 1, 2, 3, dot, 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 up to N.
Up to N. Up to N, it should be up to N or something else.
Infinity.
It can be
Up
anything,
to-
right? It's not up to N. If I'm going to writing, see what we are saying. Poisson distribution, N should be large, right? We don't know even what is the value of N it will take, correct?
No, sir, this and not. Infinite.
Okay. So here X will take 0, 1, 2, and so on. So basically, this is just a PMF of Poisson distribution. This PMF you can get by the derivation of the binomial distribution. In that case, we are taking P as a lambda by N, and we'll apply NCX, P raised power X, Q raised power N minus X. That I have told you. We are not going to do the derivation of this because that's not in the course, but I'm just going to give you some rough idea. So we are taking NP as a lambda, right? So here P will be what? Your lambda by N, something like that. So in binomial, we are going to use NCX, P raised power X, 1 minus P raised power N minus X. Then you have to replace this as lambda by N, this 1 minus lambda by N. Then it's a limiting case. So I will take limit N tending to infinity, then N choose X, then lambda by N raised power X, something like that. We'll get this PMF actually. So that's not required here. Okay. You can keep in mind this PMF of this Poisson distribution. Now, and one important thing, it's the easiest or good thing also about Poisson distribution. What is the expected value of X? It's a lambda, right?
Lambda.
And variance is also same as the lambda. In case of Poisson distribution. Okay. So this is just a basic thing about Poisson distribution. So let me take one example for that, then I will move to the some activity question. Okay. So suppose I'm saying, let me write down that question. Okay. So suppose I'm saying number of accidents per week in a factory, or it can be anything. can be modeled by Poisson distribution. Okay, so I think this example is covered by ma'am, right? With a mean of 0.5. Okay, with a mean of 0.5. So question says, suppose I'm saying, what is the probability that in a particular week there will be, let's say, there will be exactly 2 accidents. So what is the meaning of probability of exactly 2 accidents? Anybody? So that
X
means
is equal to 2.
correct. So x is equal to 2. What will the my x? X is nothing but a number of accidents per week in a factor, right? Now, if see, it's saying with mean of 0.5, correct? Sir, I
Expectation
know
is given.
expectation is given. I know in the case of Poisson distribution, lambda is same as expected value, and that is same as the variance, correct? So here value of lambda is 5.
0.5.
Sorry, yeah, 0.5. 0.5. So what will it? Okay, what is the PMF? PMF e raised power minus lambda
0.5
raised power x
2
and divide
by
by
2
x.
2
factorial.
Okay. If you will calculate it, I will get the answer. Now, suppose I'm asking what is the probability that there is at least 2 accidents,
X greater than or equal to 2.
correct? So be clear with, because sometimes people make mistake. They are not able to differentiate between at least and at most. So at least 2 accident means there
X greater than or equal
correct.
to 2.
There can be more than 2 accidents,
2.
right? So what? Okay. So what should you prefer in this case? X is greater or equal to 2. That means what I have to do, since we
1
know
minus
X can take 0, 1,
0,
2
1,
and so
2.
on, correct? But it's not a good thing here. See, here we have to add e raised power. See, here we have to do like this. Probability x equal to 2 plus probability x equal to 3 plus 1, right? So the good
Yes, sir.
thing is
1 minus probability
yeah,
of
x
probability
less
of
than 2.
2.
X less than 2, right? Because
Yes, sir.
equal to is there. So here I'm interested to take the x equal to x less than 2. So it will be 1 minus
Minus
probability
probability of x equal to 0
plus
probability of
probability of
x equal to 1.
and probability of x equal to
Fix.
2. That's all, right? So
So
now
can
what
you please explain this part?
okay,
is equal to 2.
see,
Sir, only for till x equal to 1, no, sir.
oh, okay, yeah. Great, good catch. So it will be probability x equal to 1. So why I have written like this? Because see, you know, probability of A plus probability of A complement should be equal to 1. Sum of total
Yes, sir.
probability. I'm
Yes, sir.
saying probability of x is greater or equal to 2 plus probability x less than 2 should be equal to 1 or not?
Yes, sir.
So probability x less than 2 means what? 1 minus probability x greater or equal to 2, or probability x greater or equal to 2 is nothing but 1 minus vice versa, correct?
Yes, sir.
So the same thing. So rather than adding 2, 3 and so on, so it will be this sum will be a very tedious task. So we'll take 1 minus probability x less than 2. Is this clear? So what you have to do here, we have to put the value. So e raised power minus lambda is 0.5, 0.5 raised power 0 divided by 0 factorial
0 factorial
plus
e power minus
0.5,
0.5
0.5 raised power 1 divided by 1.
1
You will
factorial.
solve, you will get the answer. Okay. So rough
Yes,
idea
sir.
is okay for everyone.
Yes, sir.
Okay. Let me take a slightly different question for this one, basically. Okay, let me take that activity question that I think someone asked a question. What was that? Activity 8, 11.1, 11.8, question number 2. Okay. 11.8, question number. Okay, before going to question number 2, I will. So yeah, question number 2 I got. So before going to question number 2, let me take the question number 3. I will come up to question number 2. So as you can see, question number 3 says the number of items sold by an online store is in an hour follows a Poisson distribution with lambda equals 2. Correct? See,
Yes, sir.
okay. So this is nothing but activity 11.8. Question number
Question
3.
3.
So what it says, the number of items sold by an online store, number of
Per an
items
hour.
sold by an online store in an hour, right?
Hour. Yes, sir.
So in an hour, it follows the Poisson distribution. It is following Poisson
In
distribution
distribution.
with
With
parameter lambda
parameter
equal to 2.
2.
But question says find the probability that in the next 4 hours, exactly 3 items will be sold. So here we have to be little bit careful because it is not asking about probability of exactly. Okay, before going to that, tell me, suppose I'm asking what is the probability that exactly 3 items will be sold in an hour. If I'm saying exactly 3 items will be sold
In an hour.
in an hour. Okay. Then
Yes, sir.
what it will be? It will be e raised power minus lambda, with lambda is 2, 2 raised power 3 divided by 3 factorial.
3
Correct or
factor.
not?
Yes,
But
sir.
here question says find the probability that in the next 4 hours.
4 hours.
So if there are that online store is able to sold 2 items in an hour, then in the next 4 hours,
8.
so lambda will be, let me denote it as lambda dash. So lambda dash will be 2 times 4, that will be 8.
8.
Correct?
Yes,
In the
sir.
next 4 hours, they so here value of lambda will get changed. So here,
So it's
for exactly x equal to 3,
3.
it will be e raised power minus lambda, lambda raised power
Lambda power
for x divided by x.
3 factor.
Okay, is this clear?
Yes, sir. Yes, sir.
Now come to the question number 2, right? So question number 2, same logic we have to apply in the case of question number 2. Question number 2 says x denote the number of radioactive particles passing through a counter in 1 millisecond time interval. Correct? This
Yes,
is
sir.
like x is denoting. Now what question says probability that number of particles passing will not be counted is 0.01.
Yes, sir. 0.0.
So it says probability that particles will not be counted, right?
Will not be.
So for this, what is the probability? 0.01.
Yes,
If I'm
sir.
saying what is
Yes.
the probability, what will the probability that it will be counted?
0.99.
999.
0.99.
0.99.
99.
99.
First, this is the first case. Second says x follows the Poisson distribution with parameter lambda equal to 3. Now, what x denote the number of radioactive particles passing through a center in 1 millisecond time interval, right? If I'm saying lambda equal to 3, that means it is denoting for 3 milliseconds.
Yes, sir. 3 milliseconds.
Correct? And
Yes,
what
sir.
is the, okay, for 3 milliseconds, what is the, what probability we have to find? We have to find the probability that number of particles counted. Be careful. We are interested to know, we are interested to find
Number of particles counted.
Correct?
Yes,
Okay,
sir.
so, and for x is unique for 1 millisecond. So for 1 millisecond, probability was 0.99.
No.
So for 3 milliseconds, so what lambda will be? It will be
3
3
into
into
0.99.
0.997 or not. So it will be, I think, 2.97.
Yes, sir.
So my
Yes.
lambda dash will be this one or not.
Yes, sir.
Question says probability that number of particles counted during a specified time interval is 3. That means you have to find
X
out
equal
the
to 3.
probability that x equal
X
to
equal
3.
to
So
3.
it will be e raised power minus lambda. That means
2
minus 2.7.
0.9.
And lambda raised power x
3
divided
by
by
3 factor.
Is it clear? I think
Yes, sir.
B option is correct. Let me see. So yeah, option number B is correct. Okay, it's clear.
Yes, sir.
I
Yes,
think
sir.
this is fourth number is just
Yes.
you can
Easy.
apply the PMF of Poisson distribution. You will get the answer. Let me come to the question number 5. I think this will help you a little bit more. Now, so question says number of persons arriving per hour in an insurance company for the insurance of their cars follows the Poisson distribution with parameter 6. Okay, be careful. It's a this lambda is taking value 6, but in an hour.
60 minutes. Yes, sir.
So question number 5. So this is lambda is taking 6, but in an
hour.
Correct. Now, what is the question says? We have to find the probability that exactly 7 people will arrive during any 90-minute period. So 90-minute period means 1.5 hour.
Yes, sir.
So this is for 1
1.2.
hour. Then for 1.5 hour means
9.
so lambda dash will
Lambda
be
is equal
6
to
into
9.
1.5.
Yes.
It will be 9.
9.
Correct or not?
Yes, sir.
And question says probability. We have to find exactly 7 people. So probability
X is equal to
is
7.
X equal to 7.
e raised power minus lambda.
9.
Lambda is for
9
x.
power 7. 7 factorial.
I mean, you just calculate this value, you will get the answer. Is this clear to everyone? Poisson
Yes, sir.
distribution?
Yes, sir.
Okay. I think let me take one question. Any doubt from activity 11.9?
No, sir.
No,
Is this
sir.
clear everything is okay?
Yes, sir. Yes.
Okay. What about this question? A manufacturing company produces medicine bottles. It finds that probability of producing 3 defective medicine bottles is 2/3 times probability of producing 4 medicine bottles. Okay. And it says,
Yes.
assuming that number of defective medicine bottles in company follows Poisson distribution. It says what is the average number of defective medicine? So to find the average
Expectation
number
of
of
X.
average, that means we have to find the value of lambda.
Yes, sir.
Okay. Susmita has raised hand. Yes, please. Yes, Susmita, do you have any query?
Yes, sir. I just want you to solve 11.3, question number 5 after this question.
11.3. Okay, I will come to that. So
11.3,
what we are,
question number 5.
okay, no problem.
Okay, thank you.
We'll come. Yeah, sure. So it's a probability of producing 3 defective medicine bottles. So
Probability of X equal to 3. Equal to
suppose I'm denoting X as the number of defective bottles produced in that company. So it's a probability X equal to 3, right?
equal to 2/3 times.
So 2/3 times
3
probability
times
of
probability of
X
X equal to 4.
So by using this equation, we have to find the value of lambda. If I'm able to find out the value of lambda, that means it is the expected value,
Yes,
which
sir.
is the average.
Average.
And by the square root of the lambda, we will find the standard
So
deviation.
here it will be, let me solve it. It will be e
E
raised power minus
power
lambda. Lambda is for 3 because I'm using
3
lambda because I
factor.
don't know the value of lambda.
Lambda.
It will be 2/3 e raised power minus lambda. Lambda is for 4
Lambda
divided by
power 4. 4
So it
factorial.
will get cancelled out here. And this will get also cancelled
Lambda.
out. So I
4.
will get here 3/2 into 3 factorial equal to lambda by. So 4 factorial I can write down the 4 into
4
3
into 3
factorial.
factorial.
3 will get cancelled out, right? And this
4
2 will,
ones.
it
2
will
ones. 2 twos.
so here lambda is the 6, correct?
6.
So lambda is 6. Let me check the answer whether it's correct or not. So yeah, it's a 6, and if you will take the square root of 6, you will
2
get
root 3.
Okay.
Yes, sir.
Okay, it's clear. Okay, someone was asking 11.3. Poisson distribution is clear.
Yes, sir.
Okay, 11.3, question number 5. Suppose that 4.5% of people living in a particular city own a Creta. So a survey has been conducted to know what brand of cars people use in the city. What is the probability that the 12th person being interviewed during the survey is the second one to own a Creta? Okay, how did you approach to this? What was your approach first of all? I mean, you had solved, right? There was some approach from your side. How
Yes,
did you
sir.
approach?
What I thought that if the 12th person is the second one, then the first one may be from the first 11 person.
Okay.
And if I, so in after that, I didn't know how to approach, because in 11, it could be anyone. So how to form it in an any discussion, I have no idea about it.
Okay. No worries. Tell me one thing.
Sir, I fix the last success in the last in the last place, and then have combinations of 1 success and all 10 failures in the first place.
Can you repeat? Can you repeat?
Like I will fix the last success, like last person to own a crater in the last place, like in the 12th place, and then I will take the other 11, of which one is success and all 10 is failures, and then and like use combinations to find the number.
Okay. Yeah, correct. So, Susmita, right?
Yes, sir.
Yeah. So basically, okay, tell me, suppose I'm saying you have to choose one people out of 11. How many ways you can do?
11 ways.
11 ways. I mean, I think it's the
11
C1,
C1.
C1.
Yes, yes,
C1.
that's what I mean.
right? Now,
Yes, sir.
so it says that 12th person. Okay, we're going to that. Let me write down. Let me define an event like this. A is first person own a creta out of 11, right?
Yes.
Yes, sir.
And B is
Second person.
12th person is the
Uh,
second one, right?
Yes, sir. 12th
12th
person
person is the second
second one.
who own the creta, right? That's the scenario.
Yes,
Now,
sir.
what question says probability of A and B, correct?
Yes, sir. A
Yes, sir.
and B.
Probability of
and
A,
B.
and because it says probability that 12th person being interviewed the second one.
One.
If 12th one is the second one, that means first will be out of 11.
Yes,
Yes,
sir.
Yes
sir.
or no? No.
Yes, yes, yes.
Tell me
Absolutely.
one more thing. How I can write down this probability of A given B?
Probability of A.
Probability of A, B, A
Anything.
union B.
Probability
No.
of A
Probability
plus
of A
probability
plus
of B.
probability of
It's
B
not independent,
minus
right?
probability.
Suppose I'm saying,
Okay.
can I write down probability of A given B into probability of B or not?
Yes, sir. Yes, sir.
Yes.
Something like that?
Dependent.
Are you
Okay.
That's
Oh,
like
yes, sir.
B,
Yes.
B and B.
Conditional
that
probability.
that multiplication rule,
Yeah.
correct or not?
Yes,
Yes.
sir.
Okay, forget about this. This is just a formula I'm going to tell you. This is the nothing but multiplication rule. So now tell me, first person is owning the creta. Now, in how many ways I can choose the first person? It can be anyone, any of the one. I mean, anyone from the out of 11.
Yes, sir.
Correct.
11,
Yes or no?
11 C1. 11
Now,
choose one.
I'm saying one person selected that one. So what is the probability of owning the creta? 0.45? No, 4.5?
4.5.
One second.
4.5%.
4.5%. That means
5%.
4.5%. That I mean, see 4.5. That means divide by 100, right? So 0.045,
It's
right?
0.045.
0.05, 0.045. So this is power 1
Yes.
because only one is owning the creta, correct?
Yeah.
Yes, sir.
Yeah.
Not owning the creta, 0.955.
0.05.
Power 10.
Power 10, correct?
0.5.
So this is for the one person who is owning the creta, correct? That means remaining 10 did not own the creta, right? Into second person is own the creta, which is 12th one. So for what is the probability for owning creta? 0.04. Did you get it?
Sir, not owning is 0.05, sir.
How?
No, it is 0.955.
So 0.955, right?
Okay.
So let me solve it on the Excel sheet itself. So 11 C1 is nothing but 11 into 0.045, right?
Yes, sir.
Square, right? I think because for the 12% is also coming out to be one time, right? So I'm writing down directly 0.045 square into 0.955 raised to power 10, correct? So 0.014 is, let me see what is the answer. 0.014 should be the answer actually. Yeah, so 0.014 is the inside the range, correct?
Yes, sir. Yes.
Okay.
Yes, sir.
Did you get the idea?
Yes, sir. Got it now.
Okay.
Thank you, sir.
Yeah.
Sir.
Yeah, please.
So why we multiply with 0.045?
Okay, so what question says? See, question is saying 12th person is the second one who own the creta, right? Till this point, if you see this box, we are considering only first person, right?
Okay.
So for I'm saying out of 11, so it's nothing but binomial here we have used, right? It
Yeah.
says, I'm saying out of 11 people, one person have owned the Creta. So it's a, see, it's nothing but n choose x, p raised power x, 1 minus p raised power n minus x,
n
right?
minus x.
For one person only. So it's a 11C1 0.0451, and I'm saying one person owned the Creta, and that means remaining 10 did not own the Creta, correct?
Not owning a Creta.
Yes, sir.
Now this is for the one people. It's saying
Okay,
12
that is the
person,
first person. That person is the first person.
first
Okay.
person, and this is for the second person. Okay,
Okay, okay, sir.
clear?
Yeah.
Here.
Okay. So I think that I'll ask that question from a practice assignment 11, question number 8. Let me see that one. After that, I will move to the that what I can say. Yeah, week 12. Okay.
12.
So let me see. Question number 8, right? Okay, shopkeeper sells mobile phones. The demand for mobile phones follows Poisson distribution with mean 4.6 per week. The shopkeeper has 5 mobile phones in his shop at the beginning of a week. Okay, find the probability that this will not be enough to satisfy the demand for mobile phones that week. Okay, so what is the meaning of this will not satisfy enough to, this will not be enough to satisfy the demand? Anyone?
Probability of failure.
Probability of failure, right? So initially it's saying demand for mobile phones follows the Poisson distribution with the mean 4.6 per week, right?
Means lambda is given
Lambda is
4.6
given, what
per
is
week.
that is 4.6, right? I think answer is given to us, right?
Yes, sir. Answer.
Okay, so here okay, so for shopkeeper has 5 mobile phones in his shop at the beginning of the week. So question says the probability that this will not be enough to satisfy the demand for mobile phones in that week. So what is, say, shopkeeper has the 5 mobile phones, right, in his in his shop, and to not satisfy the demand, what it will be?
0 phone.
0 phones.
0. Are you sure?
No mobile. 0. No. Okay, shopkeeper.
Less than 5.
Okay. Anybody else? Just think, because it's saying shopkeeper has 5 mobile phones in his shop at the beginning of a week, and probability that this will not be enough, that 5 mobile phones will not be enough to satisfy the demand for mobile phones.
Greater than equal to greater than 5.
Why?
Because if any customer needs 6 phone, then he will not enough to satisfy a demand for that week.
Okay. Okay. Somewhat true. Okay. Anybody else? No one?
Sir, maybe demand is more than 4.6 per week.
No. 4/6 is the on an average, right?
So, okay, it is on average, and the demand increases for that week.
No one? Okay, okay, just think about it. Okay, we'll discuss it at the end of session. So basically question says that demand for a mobile phone follows the Poisson distribution with mean 4.6 per week, right? So lambda is 4.6 per week, right? Okay, and it says shopkeeper has 5 mobile phones in his shop at the beginning of a week, right? So shopkeeper has 5 phones in the beginning of a week. So question is asking, we have to find the probability that this will not be enough, that 5 mobile phones will not be enough to satisfy the demand. That means what? This 5 phones, I mean, this will not be enough.
Not satisfy the demand of customer, no, sir, no?
Yes, yeah, customer or his shopkeeper. I think there is some missing statement, but we can, this will not be enough to satisfy. Okay, so here we have to think, or you people will tell me. I mean, that shopkeeper has the 5 phones in the beginning of a week, and this, I mean, this 5 phones is not enough to satisfy the demand. That means what? Okay, so just think, calculate, and take me, tell me whether you are getting the answer or not, or else I will tell you it at the end. Okay. So this Poisson distribution is clear to everyone. The idea in which scenario we have to use, or suppose some different scenario is given to you, then how you can use, like, different scenario means, let's say here it was given for lambda is going to take 6 in an hour. Then for 1.5 hour, what it will be, right? So you have to, sometimes you have to multiply, or sometimes suppose here question asks what is the probability of x equal to 7 in an hour. Then there is no need to multiply it by 1.5, right? So just we have to we have to careful with the statement. That's all about Poisson
Sir,
distribution. Yes, yeah.
I have doubt from practice assignment 11, question number 6.
This one.
Yes, sir.
Okay, what is your doubt in this one?
Sir, here our lambda will be half of.
Okay, see. On an average, 240 ambulances arrive at a hospital per hour, right?
Yes, sir.
Assuming that number of ambulances arriving at a hospital follows Poisson distribution, find the probability that one ambulance will arrive in a 30-second time interval. Okay.
Yes.
So it's a 30-second time interval. Okay. So for, okay, see, you can treat as for 1 hour, how many ambulances are coming? 240.
240.
Okay. So just think about it, and let me know whether what should be, how
So what
to,
is lambda here, sir?
in this case,
It will be
4.6.
120.
Okay.
No, sir, in this ambulance question.
That's we are going to solve, right? So in a 1 hour, 240 ambulance are coming, right?
Yeah.
Yes.
That means in 60 minutes, 240 ambulances are coming. Yes or no?
Yes, sir.
Yes, sir.
So in 1 minute, how many ambulance will come?
40.
4.
Four?
Okay, 4.
Okay. In 1 minute. So in 1 minute, 4 ambulances are coming. So that means in
Half minute.
that means 60 seconds.
Yes, sir.
So 30 seconds means
2.
2.
so here lambda will take 2.
Yes.
Correct? And in a 30-second time
One
interval, that means,
ambulance.
so probability x less or equal to 30, right? If I'm talking about in terms of 30. X less or equal to 30. So what is the answer? Answer is 0.25. No, probability
One
of 1.
ambulance is
Oh, no, sorry, 1 ambulance. Sorry.
x equal to 1.
X equal to 1.
Equal to
For
1.
ambulances, e raised to minus lambda. Lambda is for x divided
For
by x
on 1
factorial.
factorial.
So let me calculate
1
it.
by
E
e
raised for,
square. 1 by 2 by e square.
so it's a it will be
2 by
exponential
e
of
square.
minus 2 into 2. So 0.27 is the answer, which is inside the range. Okay, did you get it? So we have to
Yes,
just
sir.
think,
Yes.
here just question is very easy, right? We have to just think about the statement, how we can manipulate the things, right? Here question was at the end, it was 30-second time interval. So we have to just convert the thing in terms of 30 seconds. Initially it was for 1 hour.
1 hour.
Clear? See, this is the best, just simple calculation. Okay. Okay.
Sir,
So yes.
how to find the value of e power minus 0.32?
You can use the calculator, right?
Mm,
There will be TCS scientific calculator. Don't worry. You can use the calculator. Okay. So
Yes.
can we move to week 12?
Yes, sir.
Out in week 11.
Sorry.
Sir, week 11, 11.9, question number 1.
11.9. I was in 11.9, right? So you can ask that at that time. I was discussed. No problem. Tell me. This question is. So, okay. X follows the random variable X follows the Poisson distribution such that expected value of X square is 6. What is the value of X? So, no. Okay. What is the doubt?
X square plus X equal to 6. X equal to 2.
One second. Okay. How did you approach to this?
Expectation of X square is equal to X square plus X no. X square plus X equal to 6.
Okay. I will come to that one. I'm asking who asked this doubt.
Sir, I have chosen like 2. I took the 2 out and then did that. 2 divided by 6, so I got 3.
No, which 2 you have put it out? I'm not getting.
Sir, the square part was given now.
Hmm.
The 2 e expected x and is equals to 6, then e expectation would be 3. I did like that.
See. Say X follows Poisson distribution such that value of expected value of X square is 6, right? So I'm saying, we're going to that. Okay, let me suppose X is following Poisson distribution with parameter lambda.
Lambda.
Correct? So in case of X follows Poisson distribution with lambda, that means expected value of X will be lambda. Variance of X is also lambda or not?
Yes, sir.
Okay. If variance of X is also lambda, you know what is the variance of X?
So lambda.
Expectation of
No, I'm asking the formula, variance formula.
E of x
expectation
square
of X
minus
whole
E of
square
x of whole square.
Expected of X square minus expected
minus
value of X
expectation
whole
of
square.
X whole square.
Correct or not? And I
Yes,
know
sir.
what is the variance of X? It's a lambda.
Lambda.
Expected value of X square is 6 minus expected value of X is also, so it's a lambda square.
Lambda square.
So it will be lambda square. If you take the on the left hand side, it will
Plus
be lambda
lambda.
square plus lambda minus 6 equal to
Minus
0.
6. Lambda is equal to 2.
Right?
We have to find the value of lambda.
Correct. So because we have
Lambda
to find out, see, we have to find out the value of expected value of X, and we know in case of Poisson distribution, expected value of X is nothing but it's the same as the lambda. Correct? So we have to find out the value of lambda. So here it will be lambda square plus you can say
3 lambda.
3 lambda minus 2
minus
lambda
2
minus
lambda
6
minus 6 equal to 0.
just solve need to solve this quadrant. So
Lambda,
lambda plus 3 minus
minus
2 lambda plus 3 equal to 0. So lambda minus
lambda is equal to 2.
lambda 3
plus 3
equal to
equal
0.
to 0.
Lambda
And
equal to
here
2.
lambda will
2.
be 2 or minus 3, and we
Lambda
know
equal minus
lambda should be greater than 0 in
0.
case of Poisson distribution. So lambda will be 2. Correct answer
2.
is 2. Is this answer? Let me check. Yeah, so 2 is the answer. Is this clear now?
Yes,
Yes,
sir.
Okay. Yeah. So let's move to the week 12 concepts.
Sir, I have one doubt.
Yes, yes.
In
Please.
11.4, question number 5.
Okay, I think you have posted on the chat box, right?
Yes, yes.
Oh, okay, no problem, no problem. Question number 5. Okay. I mean, what is the reject out? An error can be recovered if the number of faulty bits is
Then are equal to 1.
One second. An error can be recovered if the number of faulty bits is less than or equal to 1. If we send a string, find the probability that the string is either correct or can be recovered. Okay, so what was your approach?
Sir, my approach was first take the probability of a string that is fully correct, like all 4 bits are correct, and then add the ones which have faults just 1 or less than 1, basically 0 and 1, and then add them. But my answer was a bit
Okay,
different.
no problem. Tell me one thing. What is the question? Question is find the probability the string is either correct or can be recovered, right? That is the question, right? Correct or no? So when it will be recovered?
When fault is either one string or less than one, basically 0 or
I mean,
1.
less than or equal to 1, right?
Yes.
Suppose X is denoting that scenario. So let me write on that one. So string is either correct or recovered. What is this? Listen. So either it will be either correct or recovered, correct? That is the scenario. We have to find the probability for that string can be recovered. And question says when I can recover it, I can recover if the number of faulty bits is less than or equal to 1. Suppose I'm denoting faulty bits as X, number of faulty bits. So X would be less or equal to 1 or not?
Yes.
That's the case. Now, so if X is less or equal to 1, that means probability X equal to 0 plus probability X equal to 1.
Yes.
Correct? This is the X equal to no, one second. Okay. If it's you can see we send a string, find the probability that it's 1 second. What is the value of n here? It's a related question.
Yes, sir. And
Okay, I thought why I'm not getting the whole information. Okay, I was worrying about actually I thought it's a direct question. Okay, no problem. So it's a string of length 4, right?
Yes.
Which can be either a bit can be either a 0 or 1, correct? So suppose transmit 4 bits. Okay, no problem. So there are total 4 bits, right? Sequence of 4 bits. And I'm saying X is equal to 0 or X equal to 1.
Yes.
Correct. And what is the probability for that bit will get changed? 0.1. And what is the probability that bit will not get changed?
0.9.
Correct. So if for probability of getting change is 0.1 and not getting change at 0.9. So for 0, that means out of 4 is 0.
Yes, that force is
Correct.
0.
And what is the probability of getting 0.1 raised power? 0. And what is the probability of that means all 4 will get changed, correct? Sorry,
Yes.
will not get changed.
Not
Will
change.
change.
Yes.
Correct. Same for 4C1,
1.
0.1 and
power
0.9 raised power 3.
3.
Yes.
We have to just calculate it.
And also we have to add, okay, we don't have to add the where the strings are not faulty at all.
No, it's a directly, it's a question says we have to find out the case where string is either correct or recovered, right? And I know when I can recover if the number of bits is less than or equal to 1. That's all.
Okay, so when so basically it is same when string is either correct is same as getting 0 error.
0 error, correct?
Okay.
I see. If I'm getting 0, that means it's correct, right?
Yeah. Actually, I added that twice, I think. Maybe that's
No,
like
no.
30 numbers.
Just calculate, or if you want, I can calculate on the my this.
I can calculate, sir. Thank you.
Okay, just calculate and let me know whether you are getting correct answer or not. Okay.
Okay. Actually, I have other doubt as well.
Okay. Yeah, sure.
In 11.2, question number 2.
11.2. Question number 2.
Yes, sir. How to find P?
Is to CDF is not coming. Okay. How did you I mean, did you think anyway?
I thought that CDF is given, we have to find the like the probability through CDF, but I was not able to get it. And I'm also confused, like, should I add all the probabilities or should I give just one probability? I was confused.
Okay. One more thing. Tell me, what is the n? N is the 5?
Yes.
And the 5. Now, tell me one more thing. How did you find the CDF?
CDF is given, I think cumulative distribution.
Okay, suppose it's given. Suppose CDF is not given. How will you proceed to find out the first CDF?
First value is same, and the second one you add first and second, and keep on doing that, adding them.
Okay, so CDF is, suppose I'm saying, suppose this is 0, this is 1, this is 2, this is 3, this is 4, something like that. Before 0, taking value 0, and from let's say I'm saying less than 0, it's from 0 onwards. Okay, it is taking some value till 1. Okay, suppose this is some probability. Okay, and there is jump, and from 1 onwards it's taking value something like that. I can define the CDF graph of CDF or not?
Yes.
Are you getting my point?
Yes.
From 3 to 4, and from 4 onwards it's taking value 1 lesson. So this jump did nothing but denote the probability at that point.
Yes. Yes.
Correct or not? No. So what is the probability x equal to 0 here? 1/24 divided by 3125.
Yes. Directly.
Correct. So probability x equal to 0 is nothing but 1/24 divided by what was that?
3125.
3125. Correct. And I know what is the probability x equal to 0? N choose 0, right? P raised power 0, 1 minus p raised power 5. Sorry, it's here n is 5, correct? So can you find out the value of your value of p here? So it's a 5 c 0 means 1.
4 power 1
so
minus
1 minus
p
p raised power 5. It's
4 by 5 whole power 5.
Okay.
4 by 5.
Here you can find
4
out.
by
Or else
5.
see, in such scenario, good thing to start with either from the first value or the last value. So last value is nothing but 1 minus 3125 divided by 3124 divided by 3125, right? For probability x equal to
But will we, okay, you are finding p by solving this equation.
yeah. From here I can solve. Okay, for p equal to 5, let me tell you one thing. It's a 1 minus 3124 divided by 3125, right?
Yes.
Now tell me for p x equal to 5, that means 5 choose 5, p raised power 5, 1 minus p raised power 0. So from here you can also get the same value, right? So it will be 5.
1 by
so it
1 by 5.
Yeah. 1 by 5 is the answer.
0.2.
0.2 is the answer.
And
Basically,
for Q,
sorry,
and for Q, in next
Q is
question.
nothing but 1 minus p.
Okay.
Okay. Sometimes we
1
denote Q as a
4 by 5.
failure probability actually. Probability of failure.
Yes.
P is denoting the success probability and Q is denoting the failure probability. Okay.
Failure problem.
Okay, sir. Thank you.
Okay.
Q is 4 by 5.
Okay. Clear now? From week 11, it's okay for
Yes,
everyone?
sir. Yes.
Okay. Okay. Great. So let's move to the concept of week 12. So far we discussed about discrete random variable and some, some type
Continuous.
some discrete random variable and some distributions associated with that. Now we'll move to the continuous random variable. What is the continuous random variable? Continuous random variable is the nothing but it can take, first of all, measurement will be there.
Interval of
We cannot count. First thing, second thing is that it can take any value between an interval. Right? We are not interested to at a particular point. So we are rather than taking a particular point, we are interested to know interval things, right? So what is basically it's nothing but it's a continuous. So in case of continuous, we are going to denote the PDF. See, in case of discrete, we created PMF, probability mass function, right? Here we created density function, right? So density means because we are interested in an interval. Okay. So what is meaning of interval? Suppose there is one function which is something like that. It can be anything. Let's say this is the one function. Okay. So this is the function fx. This is the value x. Suppose I'm asking, question is what is the probability that probability x will take value between a and b? So here I'm interested in a density, not for a particular curve. So for whether you are interested in density, that means it's the same as I'm interested to find out what is the probability to find the area between a and b. And in case of continuous, there is not a meaning of single point. Okay, because probability at the singleton point is nothing but 0. Because it's taking continuously, because See, area at a particular point is not, doesn't make any sense, right? So
Yes,
we have
sir.
to see the what is the area. Okay. And see, sum of all the probability should be equal to 1 in case of
1.
discrete. So here
Yes.
area under the curve should be 1.
Equal to
1.
1.
Okay.
1.
And if you are going to find out the area, how you can find out the area?
Integration.
By integration.
By integration. What is the integration?
Integration
Integration is
of
nothing
From
but
a to b
continuous.
of fx dx.
No, I'm not asking in terms of integration. Nothing but continuous summation, right?
Yes, sir. Continuous sum.
See, continuous sum. That's why if we are not able to do the continuous sum, then we are moving to the integration, right? Because
Yes,
it's continuously we have to add, because it can take any value between those two, between that interval, right? Okay.
Yes.
So continuous summation is nothing but integration. Integration in here we'll get some value. Okay. Now, as we
Sir,
know, yes.
at point A or B, it is 0.
Yeah. At a single point, it will be 0 because see, area at a single point, under a single point, what this doesn't make any sense, right?
Yeah.
Okay.
Okay.
So now, so this is something we have to do. So basically, if I'm saying probability that A is less or equal to X less or equal to B, that means what you have to do? I have to integrate my function from A to B. Okay? Now, suppose I'm saying A less than X less or equal to B. Again, I have to integrate from A to B, not A minus 1, because probability at a single point is 0. So that means probability if I'm saying A less than X less than B, it's the same as probability A less or equal to X less than B and equal to A less than equal to less than X less than equal to B, or probability A less than X less equal to B, because in case of continuous random variable, probability at a single point will be 0. And we know from the discrete distribution what is the two main points or two main properties of probability.
Probability of X greater than or equal to 0.
0, or it should lie between 0 and 1.
Yes.
Correct?
Yes,
so probability should be like 0 and 1. And so
summation of probability
summation of
the probability
is equal to 1. So in case of continuous integration throughout the range, I'm writing minus infinity to infinity because I'm defining in general. Minus infinity to infinity means integration throughout the range will be
f of x dx equal to
should be
1.
Sir, I just joined. Can you please tell what are you doing today?
Sorry?
I just joined. Could you please tell what are you doing today?
Okay, so today's session we have discussed Poisson distribution from week 11, and now I have moved to the week 12 concept, because week 12 there are two concepts we have not discussed this uniform and exponential. Okay, so that's why I'm going to introduce the concept of
because I just
your voice is breaking in between.
Sir, now what are you discussing? Because I just joined.
I'm just discussing this continuous random variable.
Week 12 concepts.
Okay, I will start it just a few minutes before week 12 concept. Okay. Okay, so as in case of discrete, we know sum of all the probabilities should be equal to 1. So same thing, area under the curve should be equal to 1. Right? And I was discussing that, okay, now one more thing, that probability at a single point, so that means minus a to a, if you integrate these things, you will get the 0 actually, right? So that's the probability at a single point you will get 0. Now what is the CDF? I think you have discussed, I mean, you had done in I'm not asking about the full form. I'm asking what is the meaning of CDF actually. Why
integration from minus infinity to
you are telling me formula. I'm asking what is the CDF? Why? What is the need of CDF actually?
for continuous random variable x.
I can find out the CDF for a discrete random variable also.
Sir, I think it tells us how much change is accumulated in between two variables, between two values. Sorry.
Okay. Anybody else?
Variability between two points.
From where a variability came, I don't know. I'm not getting your point. Why people are saying variability? Let me start with the discrete. Okay. Suppose x is something, right, is taking some value x1, x2, x3, so on. Okay, let's say xn, for example. And I'm saying probability x equal to x. There are some, let's say p1, p2, p3, pn. Suppose I have information about random variable, and see, I'm considering here discrete. For discrete, I will introduce through the discrete. I will move to the continuous. Now, suppose question might be like this. Suppose someone asks, what is the probability x is taking value x1? Correct. What is the probability x is taking value x3? Correct. That might be a question. Now, what is the CDF? If you go to the full form, it says cumulative distribution function, right? So why this CDF has been introduced? So suppose I'm saying, tell me what is the probability x will take value less or equal to x3.
It will be
So
probability
rather than being interested at a
certain
single
point.
point,
Probability
if
at
I'm
a certain
Between an
point.
interval.
yeah, if I'm interested to know what is the probability till x3,
Till
right?
Yes.
So
Okay.
basically what we are doing, we are accumulating the probabilities till x3. Okay, we are accumulating the probabilities till x3, correct or not?
Yes, sir.
So that's is the name cumulative, means we have to accumulate the probability till x3, right? Now here for discrete, what we'll do, we'll add the probability p1 plus p2 plus p3 like this, right? So if it's about CDF about continuous, so what it means, suppose I'm saying f of a, that means probability x less or equal to a. See, f of x3 means what? Probability x is less or equal to x3, and we added the probabilities, right? P1 plus P2 plus
P2
P3.
plus P.
So in case of continuous, we have to integrate.
Area.
Let's say lower limit is minus infinity. So upper limit will be a fx dx, correct?
Dx.
So this is very helpful thing to keep in your mind. Okay, is this clear? Similarly, you
Yes,
can
sir.
suppose question. Okay, I will come to that. Okay. Okay. So tell me one more thing. What is the expected value of x? In case of discrete, I can find out the summation of x, px. Correct or not?
Yes, sir.
So in case of continuous, expected value of x means here we have to integrate integration of x, fx
Of x dx.
Whatever range will be of the x, right? Similarly, I can find out the expected value of x square. So it will be x square,
X square f of
fx
x dx.
right? So if you know x expected value of x square, expected value of x, then you can find the variance of x, right? Because I can compute the variance
minus
of x.
expectation of x also.
Okay, is this clear? Somewhat idea is clear to everyone?
Yes, sir.
Yes, sir.
Okay.
Yes.
Okay. Okay, so yeah. So first distribution in case of continuous, we'll start from the uniform distribution. Uniform distribution has two kind of distribution. One is discrete. Okay, I think that we have covered in week 10 and week 11. Now we'll move to the uniform distribution of continuous. Okay, so just give me 2 minutes. I will be back. Okay, I will start. And just think about this question, demand one. Okay, and I will come and.
Sir, at the end, can you show the entire thing which you did today?
So will you be able to do it in 5 minutes? So these things I have discussed the Poisson distribution. Okay. And then I took some doubt from practice and activity. Now I have moved to the continuous random variable. Now I will discuss the uniform distribution. Okay.
So is this from week 11 or 12?
Which one? Which thing?
Week 12.
It's from week 12,
Yes.
right?
Yes.
Okay. Yeah. Hello. Hello, am I audible?
Yes, sir.
Okay. So yeah. So let's move to that. What is the uniform distribution? Okay. I think you guys are aware about what is the discrete uniform. So what was that? What was the concept of uniform distribution? Anyone?
Can you please explain what is the question you asked here?
Okay. So I'm saying, you know the discrete uniform distribution.
Yes, sir. In week 10,
That's okay. What was that? What was the concept of uniform? What is the meaning of uniform distribution?
Has got a finite, the variable has got a finite numerical value.
No, I'm asking some layman term. I'm not asking about that technical. What is the meaning of uniform? By the word, you can tell.
Sir, every possible
constant.
outcome is equally likely.
It's a uniformity, right? There is some uniformity, correct? So every value, suppose I'm saying, suppose I roll a die, I will get 1, 2, 3, 4, 5, 6. So probability of getting each value, either 1, 2, or 3, or 4, or 5, 6, it's a 1 by 6, right? So probability is same. That means there is uniformity, right? So that was about discrete case. So what about in the case of continuous case? Suppose I'm saying X is following uniform A, comma B. So that's the notation. So what is this? So let me draw a graph. So suppose this is X. Okay, it's taking any value. This is f of X. Now, so it will take any value. So since I'm talking about uniformity, so suppose this is A and this is B. So uniformity means it will take same value from this interval to this interval. Correct
Yes,
or not?
sir.
Suppose
Yes.
this is nothing but I'm denoting as K. For example, just I don't know what is the K, but just let assume. So I mean, see, this is the uniformity case, right? Probability that area of this curve, right? This from this to this, it is taking value case. That means it will take a uniform value, right? Now, so there are two ways to find out the value of K. First thing, what is that? What is the first thing? Anyone? How you can find the value of K? The area under the curve should be 1, right?
Yes.
Correct? If area
Yes.
under the curve is 1, that means what is the area here? A to B. I mean range. And what is the fx value? Fx is value taking K. So A to B, K into dx equal to 1.
1.
So K is what? K I can take
Constant.
outside. So it will
B
be
minus
x.
A.
A to B equal to 1. It will be
K
K
times
B
B
minus
minus
A equal to 1. And K is nothing but 1 upon B minus A, right?
Yes.
Yes or no? So this is nothing but the PDF of a uniform distribution. Okay, and X should lie between A to B. Okay, and it will take value 0 otherwise. Okay, now, so this is the PDF of the uniform distribution. One, see, if you don't know integration, don't worry. There is another way. Another way is nothing but I know area under the curve is 1, and this is the rectangle. Correct?
Yes,
This
sir.
is the rectangle. What is the area of a rectangle?
Length into breadth.
What is the length?
Length
B minus
K
A
units.
into K
What is
B minus
the
A into
into
K
K
units.
K.
it's the
K.
K, and area
Yes, sir,
under the
K.
curve should be 1. So K is nothing but 1 upon
1 by B minus.
and
B minus
K
A.
I have treated as fx. This is 1 by. Okay. If you
Yes, sir.
don't know integration, you can use the direct formula. Okay. So this is the PDF of uniform distribution, continuous uniform distribution. What is the expected value of x? So you can integrate. I'm not going to integrate because that is not the case. So basically, expected
B
value of
plus
x
A
is
by
nothing
2.
but 1 second. So it's nothing but A to B x into fx dx, right?
Yes, sir.
So A to
X
B,
square.
what is fx? Fx is 1 upon b
B
minus a
minus
dx, and let me integrate
1
here.
by
So
B
1
minus
upon b minus a to b x
X
into
square.
ds. So 1 upon b minus a, it will be x square
X
by
square
2 a by
B.
sorry, a to b, not a by b. So 1 upon b minus a So it's a 2 and this will be b
B
square minus a
mi-
square.
yes.
So if you solve this, I will get b plus a, b minus a divided by b minus
B
a.
minus A.
This will get cancelled and I will get a plus b
B.
by 2. So there is, don't worry, derivation will ask in the exam, but you must know how you
A plus
how,
B by
so how we are going to find the value of this. So expected value of x is nothing but a plus b divided by 2. Okay. So you can keep in mind this one. Same thing, you can find out the expected value of x square and then you can find out the variance of x. So variance of x of uniform distribution is nothing but b minus a whole square divided by 12. Okay. So this is the variance formula. You can find out through the expected value of x square and then subtract with the expected value of x whole square, and accordingly you can proceed. Okay. So now come to that CDF formula. Actually, CDF formula is very, very important. That will help you to find out this, to solve the sum questions. So what is the CDF? CDF is nothing but, let's say, I'm denoting f of x. So that means we have to find out the probability x less or equal to x, right?
Yes, sir.
See, this capital X denoting random variable, this x small x denoting the particular value which is accepted. So what is meaning of probability x less or equal to x? That means I have to integrate. What is the lower limit of x here? X, if x is falling
minus
uniformly,
infinity.
no.
A to B.
A. Now upper
To B.
limit is x here,
B.
not B.
B. Okay, okay.
So we have to integrate a to x fx dx.
Dx.
So if I will solve, I will get, so it's the 1 upon b minus a, that will be outside, correct? So I have to
Yes,
integrate a to x 1 into dx.
dx.
So 1
X.
upon b minus a, it will be
Minus A.
x, we have
X
to
minus
integrate a to a x. So it will be
X
x
minus
minus
A.
a divided by
B
b
minus
minus a. So this is the CDF of uniform distribution. You can keep in mind, that will help you to solve the questions rather without using the integration formula. In which scenario you can use this one? Suppose I ask one question, let's say you have to find out the probability x is less at most 12, okay, and x is following some uniform distribution. So rather than integrating the things through, let's say, lower limit to 12, you can directly use this formula. Okay. There was one question in solve with a slide. If you have solved it, I think that will. Okay, let me take one activity question that will help you to understand the thing. Where is 12, 12, 12. Well, this is a from graphs. I want to do some typical question. Okay, here, let's say. So it says length of a statistics lecture has a uniform distribution between 50 minutes and 52 minutes, right? So if x denoting the length of the statistics lecture, that means x is uniform 50 to 52 minutes.
52. Yes, sir.
So that means this is the A and this is the B. And A lies between, x lies between A and B. Always keep in mind A should be less than B, right?
Yes, sir.
Now, if one such lecture of statistics is randomly selected, find the probability that lecture strength is more than 51 minutes. So I'm saying, what is the probability that x is
greater
more
than
than
51.
right? Suppose I don't want to
Strictly
use
greater.
the
1 minus.
there are two things. Either I can use the integration or not. So can I write this
1
is
minus probability of
is,
x less than or equal to 50.
and what is this?
1
X
by b
minus.
minus.
So this is f of 51.
Yes, sir.
Yes, sir.
And you know what is the CDF formula of uniform distribution?
1 by b minus a.
X minus A by B minus
divided by
A.
b minus a. So I
Yes,
can directly write down 1 minus, what is the small x is here? 51.
51.
And what is the small a?
50.
And 52 minus
52
minus 50.
So 1 minus, it will be
1 by 2.
5,
1 by 2.
no,
Half.
1 by
1 by 2. So it's a 1 by 2.
half.
Correct? So half should be the answer. Okay. You can check. Yes. So half is the answer. Okay. So this was the one approach. Another was, you can directly do it like, we have to integrate 51 to what is the upper limit?
52.
So you can directly, and what will be the PDF? PDF will be If it's
1 by B minus C.
so it will be 1 by 2, correct?
2.
So
Yes.
you can directly
52 minus.
integrate and you will get the same answer. Okay.
52
Follow
minus
the same
52.
derivation of CDF formula.
It's or you can directly use this formula, no problem.
Yes, sir.
Okay. So okay, so this uniform distribution is okay for everyone, CDF and all.
Yes, sir.
Yes, sir.
Yes, sir.
Any doubt?
No, no.
Okay, so there is something called a non-uniform and triangular distribution. So that is nothing but you have to just apply the if there is,
PDF.
just area formula you can apply directly, right? Suppose what is the area of the triangle? Half into
Base into
Base
height.
into height.
height, right?
Yes, sir.
Similarly, so just you have to apply area formula, right? Just
Yes,
some
sir.
triangle and all. Okay, so let's move to the so will you able to do the questions related to this uniformity?
Yes, sir.
Okay.
Excuse
So where the solve with us in slide?
Solid slides has been already uploaded on the portal.
Excuse me, sir.
Yes,
Sir, I have doubt in question number 4, same assignment.
this one.
Yes, sir.
Okay, how did you approach?
I didn't get this, so I didn't able to do.
Why? I mean, what is the problem? Where exactly you are facing? Let's say you are facing a difficulty to understand the statement or something like that.
Yes, sir, I didn't understand how to calculate at least of 35 minutes.
Okay, what is the meaning of at least
1 minus
35?
problem.
Hey, one second. What is the meaning of at least 35?
5 तो होना चाहिए और उससे ज्यादा भी हो सकता है.
Correct. Now, let's say question says time taken by a student to finish a quiz is uniformly distributed between 30 and 45 minutes, right? So I'm saying question says X is uniformly distributed between 30 and 45 minutes. This is the question and this is information, right? Yes, no?
Yes, sir.
So which question, sir?
This one.
Question number
Okay,
4.
sir.
And it says find the probability that randomly selected student needs at least 35 minutes to complete the quiz. So what is the meaning of at least 35? Would it at least 35 minutes?
Greater than equal to.
So probability X is greater or equal to 35, right?
1 minus probability.
Yes or no?
Yes, sir.
Yes, sir.
So who has this question?
Sir,
Pragati. Pragati. Okay. So now did you get the meaning of this one?
Yes, sir.
Now, so there is two things. If you know the integration, you can directly integrate from 35 to 45. And what will the PDF now? 1 upon B minus A. So B is 45. So 1 upon 15, right? So you can integrate these things. Or I know what is okay. If I'm saying the probability X greater equal to 35, can I write 1 minus probability X is less than 35? Yes or no?
Yes, sir.
Yes, sir.
So Pragati, tell me what is this?
Sir, now we
1
will
minus f of 35.
and B minus A.
This is the CDF, right? And in case of C, this is f of x. So this is nothing but probability capital X less or equal to x, right?
Yes, sir.
Yes or no? And
Yes,
in
sir.
case don't worry about equal to sign, because in case of continuous, this equal to sign doesn't matter. Right? So now what is the CDF? Small x minus A divided by B minus A. And what is the small x? Small x is this. So here small x is
35.
So 1 minus 35 minus what is the A? A is saying 30 and
Yes.
B is 45.
45.
30 divided by 45 minus 30. So it will be 1 minus 5 by
1 by 3.
15.
Yes,
Correct
sir.
or not?
Yes.
It will be 10 by 15. So it will be 2 by 3.
2 by 3.
So let's see. Okay, so 2 by 3 is the answer.
Yes.
Correct?
Yes, sir.
Now, you people will tell me what is the answer for this one. Without seeing, I will ask how you have computed. The probability that a student need at least 35 minutes to finish the quiz, given that he has already taken more than 30 minutes. What is the
Or 5 minutes.
there is some background noise? Okay, so kindly keep on mute if you don't have any doubt. Okay. So what is the meaning? How will you write this in mathematical notation? Probability
That P
that,
of X is greater than and equal to 35.
okay, and that's all.
30 minutes are already taken. So
Okay, then
30
more
less than
5 minutes
35.
or greater than 5 minutes you can take, sir. At most 15.
no, don't go like that. It's a simple thing. Just write down the things in mathematical. What it says, probability that student need at least 35 minutes. It's a conditional probability. People make mistake here. Probability that student need at least 35 minutes, right?
Yes.
Given that
30 minutes are
he has
have
already
already
taken more than that. That means X is greater than 30.
30.
These things we have to find out. Okay.
So how it is X is greater than 30, sir? Please explain.
What is it's written?
Already taken more.
Yes, sir, more than 30 minutes. Yes.
So what is the meaning of more than?
Greater, greater 30.
That's I have written.
Yes. Sir.
Okay. And tell me what is the formula probability A given B? Probability of A and B divided by probability of B. Yes or no?
Yes, sir.
Yes, sir.
So probability of X is greater or equal to 35 and X is greater than 30. Divide by probability X greater than 30. Correct or not?
Yes, sir.
Right? And
Yes,
you
yes.
know it is taking value from 30 to 45.
45.
And I'm saying it's a 35.
35.
Suppose what is the meaning of this? We have to find out the intersection point, right? Now,
Yes,
suppose
sir.
I'm saying X is greater or equal to 35. That means this green region.
Yes, sir.
Correct. And what is the suppose X is greater or equal to 30? That means
30.
this red region.
Yes.
Yes or no?
Yes, sir.
Yes, sir.
What
Yes.
is the common point between these two red regions?
35 to 45.
35 to 45 region is the common.
35 to
this
45.
this is the this blue region.
Yes, sir.
So that means what? It's nothing but probability X is greater or equal to 35 divided by probability X is greater than 30 or
30.
not.
Yes,
And
sir.
I know these things I can write down 1 minus probability X is less or equal to 35 divided by 1 minus probability X is less or equal to 30 or not.
Yes, sir.
Yes, sir.
Yes, sir.
Now I can apply the CDF formula of uniform distribution
X
to this and uniform
45
formula of this.
minus
Correct?
35.
And I will get the answer. Now this is this clear? So this
Yes,
is
sir.
something be clear
We can
with
use CDF formula only for at least type thing.
no, if it at most also I can use, right?
2 by
See what is the meaning? Okay, I'm saying suppose at least 35 minutes. What is the meaning of that? These things? Probability X is greater or equal to 35, right?
Yeah.
Suppose I'm saying at most 35 means
probability of X less than 35.
Less than and equal to 30.
Equal to 30.
Less than or equal to 30.
I can directly use the CDF formula here, right? Here I can use the CDF, but I have to do 1 minus probability X is less or equal to 35 because CDF is defined for the Fx is defined for the probability X is less or equal to X, right? Okay. So it's for X less or equal to X. Okay, so
Okay,
page
sir.
has been full. Let me.
Sir, f of x is CDF of x, right?
Yeah, CDF of X. Suppose I'm saying it's okay. What is the CDF? It's a probability X less or equal to X, right? Till this point, right? So suppose question is greater than
Your
that.
screen is not visible.
Yeah, I have stopped because I'm going to open this new journal to write down the things actually. So okay, so what I'm talking about, so that CDF is for defined till less or equal to X, correct?
Yes, sir.
Yes, sir.
Yes, sir.
To apply the CDF formula, if greater than is given to me, then can I do 1 minus something or not?
Yes, sir.
Yes, sir.
The same thing, right? Let me share my screen. Is my screen visible now?
Yes, sir. Visible, sir.
Yes, visible.
So that's
Yes, sir.
something I was talking about. So CDF is nothing but Fx is nothing but probability X is
Probability
less
of
or
X
equal to
is
X.
less than or equal
Suppose
to
I'm
X.
saying what is the probability X is greater than X?
1
So can I
minus
write down
probability.
1 minus probability X is less or
Probability
equal
of
to
X
X?
greater.
Yes,
Yes,
or no?
sir. Yes, sir.
That's all. That's so if something given to you like this, so there is no need to integrate if you know the formula. If you know the if you don't know the formula or you are aware about the integration, then you can directly do the integration. Okay.
Okay.
Okay, so let's move to the exponential distribution. Okay. Sorry. Okay, so uniform distribution is okay for everyone?
Yes.
Yes, sir.
So let's move to the exponential distribution. So what exponential in which scenario you can use the exponential distribution? Hello, anyone?
When the data increases exponentially.
Okay. Anybody else? No, no one?
Distribution of the amount of time until some event
Correct.
occurs.
Correct. That's all. Distribution of the amount of time. Let's say amount of let's say length of the phone call, right? So length of phone call is what? Sir, I'm interested to know the distribution of amount of time. Correct? So I mean, here exponential distribution I can use the distribution of scenario distribution of amount of time until some specific event occurs. Okay. So in such scenario, let's say I'm interested to know the length of a phone call in minutes, like that. Suppose I'm saying length of a phone call in minutes is follows the exponential distribution like that. Okay. So what is the PDF of this case? I mean, in the exponential distribution, suppose I'm writing down x is following exponential distribution with parameter lambda. Okay. So here x should be first of all greater or equal to 0 and lambda also should be greater than greater than 0. Okay. So what is the I'm just writing down the PDF formula. What is the PDF of this exponential distribution? Is nothing but lambda times e raised to power minus lambda x, and here I told you x should be greater or equal to 0. Okay, and it will take value 0. Otherwise, then beyond this range, x greater or equal to 0. Okay, so now, so this is the PDF of the exponential distribution. So basically, so what is the basically? Okay, you know what is the CDF? Everyone?
Yes, sir.
Okay, what is that? So this CDF formula and all you can keep in your mind. That will be very helpful. So what is the CDF?
1 minus e to the power minus lambda a.
Okay. So basically f of x is nothing but probability x
X
less
is
or equal
greater
to
than
x.
equal to x.
Not greater, less or equal to.
Sorry, sir, less than.
Okay. So that means what? We have to integrate from 0 to x. This PDF.
Yes,
Correct or
sir.
not?
Yes, sir, correct.
Everyone is getting? So lambda,
Yes, sir.
and what is the integration of e raised to minus lambda? Is e raised to minus lambda
Minus
x divided
by
minus
minus
lambda.
lambda.
0 to lambda. Lambda will get cancelled out, so it will be minus. It will be minus
Lambda x.
Minus lambda square.
Minus lambda and
no.
It
It's
should be
not
0
x.
to x.
It's a x. That's it's a lambda x, right?
Yes,
So
sir,
and
lambda.
minus is for 0, and it will be 1 minus is for
Minus lambda x.
So this is the value of f of x, and probability x is less or equal to x. Okay. So this
PDF.
you can keep in your mind as suppose I ask what is the probability that there will be, let's say I'm telling length of a phone call following exponential distribution with let's say parameter lambda is equal to 0.1. Then what is the probability that call will take, let's say at least not at least let's say at most 10 minutes. Okay, something like that. So what you have to find? You have to find the
Probability of
probability
One
x
minus
less
e
than
to
or
the power
equal to
minus
10.
0.1
Correct.
into
Directly I can use, right? This is the
10.
actually CDF formula for the exponential. Now suppose I'm interested to know what is the probability that x greater than x. That means I
1
can write the
minus
Probability of x less than or
x
equal
less
to
than
x.
equal to x.
Okay, and 1 minus
Then
probability x. So 1 minus
e to the power minus lambda x.
this is okay. So 1 minus 1 will get cancelled out, plus e raised to
Plus
minus
c.
lambda x, right? So let me add a space here. So it will be probability x greater than small x will be e raised to power minus
minus
lambda x, right? Okay. Now let's do that mean and variance. So, expectation of x, I'm just writing down the
1 by
direct
lambda.
formula.
1 by lambda.
1 by lambda.
So how I can find the expectation of x? So I have to integrate from 0 to infinity
Into
because x is taking greater or equal to 0 from in case of exponential distribution. It will be x f of x dx, right? So if you apply the formula, I will get 1 by lambda. So expected value of x for
Lambda.
exponential distribution is 1 by lambda.
By lambda.
And variance of x for a distribution
1 by lambda square.
1 by lambda square.
So that is
Can
something you can keep in your mind because sometimes in case
This
of
is for
this
which distribution?
for exponential
Exponential distribution.
Yes.
Okay. So you can keep in mind because sometimes lambda is not given to you, sometimes average is given to you in case of exponential distribution. So what you have to do, you have to do the 1 by lambda
Equal to e value.
Okay. Okay, let me take one or two activity question that will from where is this background coming? Who is this
Chintala.
So please keep you know on mute if you don't have any doubt because we are getting disturbed, right? So that's not a good thing actually. So here you can say waiting time in a hospital said to follow exponential distribution with the expected waiting time of 10 minutes. Ripu Sudan has raised. Is there any doubt?
No, sir.
Okay. So waiting time in a hospital said follow exponential distribution with the expected waiting time of 10 minutes. Be careful. It's not directly saying it's taking lambda is 10. It's saying expected waiting time. So what is the expected value of in case
1
of
by lambda is equal to 10.
Okay. So by the question, it's the 1 by lambda, right? Expected waiting time is given to us 10 minutes, right? So what will be the lambda? 1 by 10.
0.1.
Yeah, I mean, it's the same as 1 by 10. So that means here x is following exponential distribution with 0.1, right?
1.
So be careful, just a slightly manipulation of the statement. Question is, what is the because if you directly use the 10, you will get the wrong answer. What is the probability that a person visiting a hospital to wait for more than 15 minutes? So what is the meaning of more than 15 minutes?
Probability of x greater than
15.
Suppose
1
you
minus
don't know the
probability of-
integration. Yeah, I will come. See, just let me explain. Suppose you don't know the integration. If you know the integration, you can directly integrate 15 to infinity and lambda into e raised to power minus lambda x dx, right? Suppose you don't know the integration. So what you can do?
1
I
minus
can do 1 minus probability x is less
x
or equal
less
to
than
50.
or equal to 50.
And I know what is this? This is the CDF of the exponential distribution.
E to the power minus
1
lambda
minus
x.
And what is the
1
CDF of
minus
exponential distribution? 1 minus
minus
e raised to power
to
minus lambda
minus
x.
lambda x
So lambda is 0.1 and what is the x?
to
X is
15. 1
50.
point 1.5.
Everyone is getting this one?
Yes, sir.
So it will
So
be
this is
1.
which question, sir? Can you please scroll up?
I think you are not listening to us carefully. This is question
I-
number 3.
Sir, actually there are two sessions happening simultaneously, sir. So I'm doing both.
No. So it's not a good thing. You can focus on one session, either here or in the another one. Okay.
No, sir.
Otherwise, you will
Actually,
get confused. What if say? Okay. So what's my suggestion? You can watch one session, either this or that one in which you are interested, or another watch. You can watch on YouTube later. Okay. That will be easy for you also, right? Otherwise, you will be like you will not be able to catch up with the concept. Okay. So here it will be e raised to power 1 minus 1. Okay. So 1 will get cancelled out. So e raised to power minus 1.5. So just compute this value, you will get that. Okay. Is this clear to everyone?
Yes, sir.
Will you able to do the questions related to this one?
Yes, sir.
Yes.
Okay.
Sir,
Yes.
how to solve
Sir.
first questions?
How to?
Solve first question, sir. Yeah, this one.
Formula.
What is the value of K, right?
Yes.
2.
Okay. Tell me there are two things. First thing, you can directly tell the value of K is 2.
2.
Tell me how.
Yeah.
How did I do?
Lambda e की power minus
Lambda e power.
By comparing the formula of PDF.
Lambda into e raised to minus lambda x, x is greater than this is saying K into e raised to minus 2x, right?
Yes, sir.
Yes.
So lambda
K
is 2, that means K is 2. Another thing is, this is not a, this is just a quick idea, but good approach is for any kind of question. This is constant, right? I don't know the constant. So what I can do, I know integration under the curve should be equal to 1. Yes or no?
Yes.
Yes, sir.
What
Yes,
is
sir.
the range? 0 to infinity.
Infinity.
And what is the PDF given to us? 0 to infinity. K times e raised to minus 2x dx equal to 1.
K is constant.
Correct. Now K is
Yes,
the
sir.
constant. K will be outside. If I will integrate, I will
E
get
की
e raised to
power
minus 2x.
minus 2x by minus 2.
Okay. So this is the
0 to
integration of.
infinity. 1.
Now, so it will be minus 2k e raised to minus infinity minus e raised to 0 equal to 1. And e raised to infinity is 0 and this is the 1.
It will be minus K by 2 only.
Yeah. Correct. Great. So minus K by 2 and it will be 0 minus 1
0
minus
minus 1.
1. Yes.
Sir, how
K by
did that
2.
2 come? K into e raised to the power 2x.
Because integration of e raised to minus ax is nothing but e raised to minus ax divided by a. Sorry, minus a. Okay. This is the integration formula.
Okay.
So here minus will be
K
plus
by 2 equal K equal to 2.
So you can see that I got the same value. Okay. Clear?
Okay.
Yes. Okay. Yeah. So okay. So
I
let's
want to see the solution. So please
first-
scroll down little.
yeah.
Thank you, sir.
Okay. Yeah. Great. So is there any doubt from this uniform or exponential?
No, sir, clear.
Clear for everyone? Any doubt from that solve with the slides which you have uploaded on the portal? Because there are that slides has contained some questions. Yes, no?
Sir, I have a doubt from this assignment 12.3.
Okay. Which question?
Sir, question number 4.
So can you just explain what the one to explain at the last, sir? F
One?
of x is equal to lambda e per minus lambda.
The last thing which I have done. This
Yes,
one?
sir. Yes, sir.
Where you are getting difficulty?
Can you just go through the entire question once?
So question said you have to find out the value of k, right? So there is two things. I know what is the PDF of exponential distribution, lambda into e raised to minus lambda x,
Yes,
right?
sir.
So
Yes, sir.
by the quick idea, it's some smart approach. It's a 2 is given to us, right? And I know
Yes, sir.
lambda into e raised to minus lambda. So this is the lambda. So this would be lambda. So I can
Yes,
directly say k is the 2, right? Or another
Yes, sir.
approach is I can integrate. I know area under the curve is equal to 1. Okay.
Yes, sir.
If I will integrate, I have to integrate the PDF. So it will be k times e raised to minus 2x dx. And we know integration of e raised to minus ax is nothing
Yes,
but e raised to minus ax divided by minus 8. So it will be e raised to minus 2x divided by minus 2. So 0 to infinity. If I will put the upper limit, I will get e raised to minus infinity, which is 0. And if you put the 0, you will get 1 because
Yes,
e raised
sir.
to 0 is 1 and minus will get it will
So
be
k is 2 s.
Okay. The same thing you can do from here or you can do from. So this is the general approach for any kind of distribution. Suppose you have discrete distribution. So in case of discrete distribution, how you can find out the value of a constant? So I know sum of all the probabilities equal to 1, right? Then you can do. And in case of continuous, I know area under the curve is nothing but area under the curve is nothing but 1. Okay. Clear? Yes, no?
Yes, sir.
Okay. So any doubt, any question? Or okay, let's yes.
Sir, 12.3, question number 4.
12.3. Okay, what is your doubt? Question number 4.
Number 4.
Yeah, what is doubt? Exactly doubt I'm asking.
Number 4, I was able to solve that question.
Okay, did you do the second question?
Yes, sir.
What is the correct one?
Sir, just
Okay, let me see from there. Okay, so this f of x you can find out from the area of the curve, right? Because if you see x less than 0, so it's a 0, right? Because there is not any value. Now if you see 0 to 0.5, so it is taking 0.5, correct?
Yes, sir.
Yes or no?
Yes, sir.
And what about 0.5 to 1?
That's 1.
It's a 1, right?
Yes, sir.
Okay. Same thing. Now question says probability x less than 0, x less or equal to 1.5.
So, sir, we will add from 0 to 1.5.
Integrate.
1.5 will be from where, right?
Yes, sir.
From 0 to this thing. 1 less or equal to x less or equal to 1.5, right?
Yes, sir.
What is it's 0.25?
Yes, sir. It will be 0.25.
Okay. What you
It's a PDF function.
One second. 1.5 will be this one, right? This point.
Yes, sir.
Can you see my cursor?
Yes,
if
sir.
this is 1.5, what will be the area? See, it's a 0 to 1.5. You can directly compute the area. So from 0 to 1.5, so one line will be at this 0.5.
One rectangle.
Yes, sir.
One rectangle. What will be the area for this one? 0.25.
Yes,
Yes,
sir.
sir.
Area of rectangle is
0.5
length into breadth. 0.5 into 0.5. That is 0.25.
0.25.
25. Yes,
Plus
sir.
one line I can draw
0.5
at the one.
Yes,
0.5 into 1, so sir, 0.5.
0.5. So 0.5 plus 0.25. So that is 0.75.
Yes, sir.
Now one line I can draw at a 1.5.
Yes, sir.
5 into
area of this one, this
0.25.
0.5
0.125.
0.125. So now it will be 0.875.
Yes,
Yes,
sir.
sir.
Got it? Okay, that is something so it's not a non-uniform. But if you apply the formula of area, you will get the answer. Okay.
Okay.
Clear?
Yes, sir.
Okay. So let's do just a quick recap that suppose I'm saying x is uniform a comma b, then what is the PDF? 1 upon b minus a, and x should lie between a to b. Correct or not? And what is the CDF?
X minus a upon b
X minus a.
X minus a divided by
B minus
a.
And what is the expectation value?
Lambda.
Lambda.
Sorry, sir. A plus b by 2.
And what is the variance?
A minus b to the whole square
B
by
minus
12.
a.
So it is same.
It's the same, but good thing B minus a, because why I'm saying, because
B is
B
a
is
greater value.
greater than a. Okay. Yeah.
Okay.
Either way, it's a square. You will get the same answer, but you can keep in your mind B minus a. But okay. So suppose that's this is very helpful. If you don't know the integration, you can directly use the CDF formula. Okay. And what suppose I'm saying x is following exponential distribution with parameter lambda. What is the PDF? Lambda times e raised to minus lambda x. Lambda
greater than 0.
So here f of x is an equation of the function, right?
Yeah, it's a function of x, right? It's a PDF. In case of discrete, we are denoting as PMF, right? There it's a PDF, it's a density function. Okay, just a notation. You can write down y equal to fx, doesn't matter. Okay. And what is the capital F of x? So capital F of x denoting the CDF. So what is the CDF in case of exponential distribution? Anybody?
1 minus e to the power lambda x.
If I want to find the probability x greater than x, I can do 1
e to the
minus
power lambda
probability
minus lambda
x
x.
less or equal to x. It's a e raised to power minus lambda.
Lambda
So
x.
you can keep in mind this one, and you will get this one 1 minus by doing that. What is the expected value? 1 by?
1 by lambda.
1 by lambda.
What is the variance?
1
1
by
by
lambda
lambda
square.
square.
Okay, suppose question says rather than giving that lambda directly, it's expected time. I can find out the value of lambda, right? Yes or
They
no?
can also give us the variance.
Variance also. If suppose I'm saying that length of a phone
Variance
call
is
is variance for
1
that
by
is
8.
100.
Sorry, 1 by
Suppose
6.
it's 100. Okay, so you can find out the lambda square is 1 by 100 and lambda it will be
1 by 10.
0.00.
Sorry, 0.1.
Okay, so that is something, just a simple thing. Okay, it's you can keep in your mind. Okay, is this clear?
Yes, sir.
Anybody, anything else?
Yes, sir, clear.
I hope you got the concept of week 11. I think, did you solve the questions of solve with the PDFs, or it's still remaining?
Some questions are remaining.
Okay, so try to solve that one. Okay, if you still, I mean, you have any doubt, we can discuss that. Okay.
Sir, there is one question. 11.9, question number 4.
11.9.
Question number 4.
Okay, you joined late.
No, sir. I was there.
Okay, 11.9. Let me go there. Hey, you could ask at that time, right?
So you were discussing week 12, continuous. So
That's why you joined late.
Okay.
Because I was there in the week. Okay, no problem. I don't have any problem. So question number 4, right? So what is the question? Say X follows Poisson distribution such that 3 times probability X equal to 2 equal to 6
Sir,
times.
wait. Let me check the question. Wait, please.
Sir, after this, can you explain one formula?
Sorry?
After this, can you explain one formula?
Formula?
Yes,
Sir, I also have 3 questions, sir.
Continuous variable variance formula, that is integral x integral bracket x minus e expectation of x the whole square times fx dx. This formula, how it came?
No. Can you repeat? What you're talking about?
In continuous variable, we have expected value formula ex equal to integral x fx dx. This I understood, but how variance is equals to integral bracket x minus expectation of x and whole square of that times fx dx.
Okay.
That formula, can you explain how it came?
See. Let me add a page, just 1 second. Now tell me, you are saying expected value of x is nothing but integration of, I can find small x fx dx, correct?
Yes, sir.
Suppose I'm saying expected value of x is square, then how will you find out?
X square fx dx.
Expected value of x cube?
X cube fx dx.
Okay. Now, suppose I'm saying expected value of x minus a whole square.
This will be x square plus a square.
No, I'm not asking about the square. Just tell me.
X minus a whole square times fx dx.
Right?
Yes, sir.
And what is the variance of x? Expected value of x minus expected value of x.
Sir, this I do not understand how this formula came.
This is the variance formula.
The variance formula is e x square minus e of x the whole square.
Now that formula you are getting from where? Okay, basically variance is defined expected value of, basically it will tell you what is the deviation from its mean. Okay, this is the variance formula in general. Okay, this is the variance formula. What is the deviation of random variable from its mean? So mu is nothing but denoting the expected value of x. So expected value of x minus expected value of x I can write.
Sir,
Okay.
this is for which one, sir?
Uh,
Sorry to ask the question.
So he is asking how
If
this
it's
formula
for
came.
is
So
the question. Yes.
basically variance is defined like this. Variance of a random variable, nothing but we know, I mean, we have to find what is the expected value of difference from its mean. We have to find what is the deviation of that random variable from its mean. Okay. So if you solve it, if you equate it, I mean, if you solve it, what I will get? X square plus mu square minus 2 times of x mu. Correct or not?
Yes, sir.
Just put the expectation inside the bracket. So it will be expected value of x square plus mu square, because expected value of a constant is the same, right?
Yes, sir.
Minus 2 mu expected value of x. Yes or no?
Yes,
So
sir.
expected value of x square plus mu square minus 2 mu and
Yes,
what
sir.
is the expected value
Okay,
of x? The mu, right? So it will be expected value of x square plus mu square minus 2 mu square. So it will be expected value of x square minus mu square. And what is this mu? This mu is nothing but expected value of x. So it will be expected value of x whole square. So that formula, which you remember, that formula is this one, right? And
Yes,
this
sir.
is the same as this one, because variance is defined like this. If you talk about the observation, what we are doing in case of observation, we are doing 1 by n summation of xi minus mu whole square, right? If I'm talking about population variance, right? In week 3 and all. So what we are doing, we are taking the average from each observation to its mean, right? We are doing like that. So here it's I'm talking about random variables, so it will be expected value of x minus expected value of x whole square. That's all. Clear?
Yes, sir.
Okay. Yeah.
So I have a basic.
Thank you, sir.
Yeah. Yes. Yes.
So I have a basic question.
Huh?
So it's somewhere I read that PDF is not unique.
Sir, I have a question.
Yeah, one by one.
So I read in a book.
Actually, I have doubts in 3 questions, sir.
Yes, just one by one. Don't please.
So I read in a book that the PDF is not unique, but the definition of PDF which is given in the lectures actually implies that it should be unique to a random variable. So how does that work?
PDF? No. Can you repeat? I'm not getting your question. What? Oh, okay. What is meaning of? I mean, what do you mean by unique?
So I was studying this book about probability called Introduction to Probability by Sheldon Ross.
Okay. That green color book, right?
Yes, sir.
Okay, I got.
So it says that a PDF cannot be unique. There can be many PDF to the same random variable.
Same random variable. It's just like that. Can you send me the picture of that one? You know, discussion forum or discourse?
Yes, sir.
Okay, so just send me the picture of that, like you're saying PDF, because if suppose I'm emphasizing like, or I'm fixing axis following uniform distribution, then it will be 1 upon b minus a, right? If I'm like if I'm specifying that distribution.
Yes, sir. They are calling it standard PDF, but they are saying that PDF can be anything like scaled up or down through a constant.
That can you do, right?
Sir, so which definition should we stick with? The one with the lectures or the one in the book?
No. Okay, what you can do, just take that picture of that line or that page, send me. I will look and I will take a look on that. Also, for this foundational level course, just go through this one. Okay, like suppose I'm specifying x is following uniform, x is following exponential, like that. Okay, or Poisson and all. And just take me that picture of that one. I will take a look on that. Okay, what is that? Okay.
Yes, sir. Thank you, sir.
Yeah. Great. Yeah, someone is asking question.
Sir, how to get in the discourse?
Discussion forum, you guys have access, right? Google forum.
Yes, a Google forum we have.
That's the same thing I'm talking about. You can post.
Okay.
Yeah. Someone is asking me any.
So 11.9 question 2.
Question 2, I think I have done.
Okay, sir, I will watch the recording.
Okay.
I have joined a little bit late.
That's why I asked you, right? Let me go through. go that point. Where is that? We had discussed that the same thing. I took that doubt one. Yeah, this one. See, lambda is the 6, right? So it's
Yes,
nothing
sir.
but probability x equal to 3, nothing but 2 by 3 times of probability x equal to 4, right? So what you have to do, just you have to apply the PMF formula for the probability x equal to 3 and PMF for equals to x equal to 4. You will get the lambda equal to 6. And we know in case of Poisson distribution, expected value of x is nothing but lambda. Variance is also lambda. So
Yes,
lambda
sir.
is 6, that means expected value is 6. And variance is lambda, that means variance is also 6. So next question was standard deviation of x. So it will be square root of 6. Okay.
Okay, sir. Thank you.
Yeah. Great. Okay. Anybody, anything else? Math one is there. Revision session is going on. It's a normal week.
It a
PYQ.
TA session, sir, of
Sir, I
PYQ.
have one doubt, sir.
Yeah. Please.
Actually, question 12.1a, question 2.
12.1a, right? Okay. Just a minute.
12.1a question.
Yeah, no problem. Let me go there. Okay, what is doubt? Yeah, please tell me what is your doubt? Hello.
I think she is gone for a math session because she is taking both the session.
Sir, will additional content come in term?
No. Additional content will not come in the term exam. Okay, it's just for your knowledge. But try to go through that because it will be very
Yes, sir.
helpful.
Yes, sir. Okay, sir.
When you will go for, I mean, if you are taking stage 2 next term, it will be very because without normal distribution, statistics. I mean, it's a very important thing. Normal distribution. Okay. Yeah. So
Thank
what
you,
is
sir.
doubt?
Thank you, sir.
So for that lectures, we do not have questions to practice, na?
No. Pragati asked this doubt, right? CDF?
No, sir. Sir, I have doubt in 12.3, question number 5 and 6. Sir, I
Okay.
think the girl asked this question, she has left.
Okay, I don't know what is the exact doubt. So okay, so for that question, CDF is nothing but you can directly apply the formula of since it's a uniform distribution, right? Or else what you can do, you can just integrate throughout the range, you will get the CDF formula. Because f of x is nothing but probability x is less or equal to x, so just integrate lower limit to x, that PDF you will get the answer. Okay. So you have doubt 12.3.
Yes, sir. Question number 5 and 6.
Question number 5 and 6. Okay. So how did you approach? First of all, what was
Sir,
your
actually,
approach?
I lost my connection, sir. Can you please explain it again? 12.1 question.
I was there. Okay, what is your exact doubt? I'm asking. Hello.
Question 2, sir.
Question 2 is okay. What is your exactly doubt? I'm asking. What is your exact doubt? Whether you are getting difficulty.
So, sir, can you just explain the question, sir? I'm not able to solve it.
Okay, so basically question number 2 says we have to find out the f of x, right? What is the capital F of, first of all, tell me. Hello. Let me check the answer. Explain through it. Okay. So what is the capital Fx? Is it there?
She's there, sir.
Yes, sir. I'm having some network issues. That's why.
Okay, no problem. Tell me what is the capital Fx? What denotes what is the capital Fx? What denotes the capital Fx? First of all, see,
Random variable.
it's not a random variable. It's a CDF of a random variable. So small Fx is what? From where you got the 0.5, right? Small f,
Yes.
f of x, right? Because it's nothing but I mean, you can do length into breadth, right? Something like that. Yes or no? So same thing. See, you can see PDF is nothing but 0.50 and less than 2. I mean, x is lies between 0 and 2. What is the CDF? So CDF basically. So what is the range? First of all, what is the f of x? It's taking 0.5 and range is 0 to 2. Yes or no? And it will take value 0
Yes,
otherwise, right? Now, what is the capital Fx? Capital Fx is nothing but integration. Okay, first of all, probability x is less, capital X is less or equal to small x, right? So what we have to do, we have to integrate the 0 to 2 small fx dx or not. So 0 to 2, so it's a 0.5 dx. So 0.5 will be outside the integration side, 0 to 1 into dx, right? So it will be 0.5, not 2, it's a x. I have made a mistake. So it will, because we have to integrate till x. No one has pointed out. So it will be 0.5. It will be x, 0 to x. So if you put upper limit, it will be 0.5 x minus 0 to it will be 0.5 x. So CDF will be 0.5 x and less than 0. Before 0, it will be 0. And after greater or equal to 2, it will take value 1. Okay. Yeah, so
Yes, sir.
clear? Okay, someone asked 12.3 this one. So what was your approach? Can you tell me?
Second question number 5.
I know, I'm asking what was your approach for the question number 5? How did you approach? What was your first thought on this question? Or anyone
Sir,
else?
I did like that 10
Area.
to 12. First draw a line and there was a one rectangle, one triangle, and then 12 to 15 a rectangle, then a triangle like this.
16, 12.
Okay, first of all, this is what is the graph? What graph state? What kind of graph is this?
Non-uniform.
It's a trapezium, right?
Yes, sir.
Okay, let me draw it. 10 to 16, 12, 4 in between. Yeah.
Ten to 12. Indra.
10, 18. Suppose this is 10. Okay, I'm just writing the things which we have required. Okay, 10, 18, 12, 12, 14. This is the 16. Okay. Okay, so just treat this as a straight line. This one should be little bit straight. Okay. So this is the trapezium. Yes or no?
Yes, sir.
And in trapezium, we know, suppose this is A, okay, and this one is the B. Okay. So what is the area of a trapezium?
Half into base into parallel sides.
1/2 into base into sum of parallel side into height.
So simply A plus B by 2 into H. Suppose this
Yes,
is the
sir.
height, for
Yes,
example.
sir.
Okay. So now tell
Yes, sir.
me, area under the curve should be 1. I know.
Yes, sir.
So this should equal to 1.
1.
What is the A? A
is 4, sir.
is 4. 12
Yes,
to
sir.
16, right?
Yes.
So
Yes,
A
sir.
is
Yes.
4 plus B is 8.
8.
Divide by 2 into H equal to 1.
1.
So it's a 12
6.
by 2 into H equal to 1. So this is 6. So 6 times H equal to 1. So H will be 1 by 6.
Yes, sir.
Right? So if you see the answer, so 1 by 6 is 0.
And 0. 0.2.
0.16 something.
So I mean,
Yes,
1
sir.
something
0.
that's inside the range, right? Now,
Yes, sir.
question number 6, what is the probability that delay in train arrival is less than 15 minutes? Okay. So it's asking about less than 15 minutes. So less than 50. So 15 will be somewhat at this point.
Yes.
Okay. So it is asking
Yes.
about less than 15 minutes, correct? So what will be
Yes.
the area? So it's again a trapezium kind of things.
Yes, a
So,
trapezium.
Yes, sir.
the probability x less than 15 means what? So it will be, what is the A plus B? Now what is the new B?
New B is 5.
15. Yes, 5.
5.
5 plus what is the
And
new A?
A is also
3, sir.
3.
3,
Divide
sir.
by 2. What is the height? Height is the 1 by
1.
6.
Yes, sir, 1 by
1 by
6.
6.
1 by 6.
So it will
4
be
by 6.
8 by 2
By
into
fi-
4 by 6. That means 2 by 3,
2 by
which is
3.
0.67 something, right?
Yes, sir. 0.6. So
Clear? So just
6.
you have to apply the formula of trapezium. Okay. Clear?
Yes,
I think,
sir.
Yes, sir.
okay. Yeah. Okay. Is there a, yes?
Sir, I had a doubt, but it was not from week 11 and week 12. Is it okay to ask?
Yeah. Please go ahead. It's a
Was just
general
a
or
small doubt.
it's a general doubt or?
No, sir, it's
No problem.
statistics doubt.
Yeah. Please go ahead.
Sir, there is a question in week 2 practice assignment 2.2. 4, 5, 6, 7. Fourth question, sir. I'm unable to understand this. Why this option is correct in the fourth, like last size as jersey, if it is the median of the size of jerseys. Week 2 practice assignment 2.2 question. Fourth.
Feedback has been written there, right?
Yeah, it is written, sir, but I'm not able to understand that. Like, I didn't get the reason correctly. I didn't find it correct. Like, there's also an option size and jersey if it is the median of the size of jersey. I'm in a doubt, like why it is not the answer and why that.
Okay, no problem. Okay, so what we can do?
Sir, can you solve activity question 11.2 question 2?
Which question?
Activity question 11.2 question 2.
Okay, I will come to that point, Isita, right?
Yes.
Yeah, okay, I will come. Okay, no problem. I think your voice is breaking. Question number 2.
Sir, activity question 11.2 question 1.
What is the value of n? You're talking what is the value of n?
Yes, sir. I think I'm not sure of this concept.
This one?
Yes, sir.
I have solved it. You can rewatch. Okay. I have solved it in the PDF. I think you have joined late, maybe. But
Yes,
okay. This is the approach actually. So just take the probability x equal to 0 or probability x equal to 5. So what you will do, n is the 5, right? You can see from the CDF also. So you can use 5C0 p raised to 0 1 minus p raised to 5. So you can convert this in some it will be something raised to 5. 5 will get cancelled out, or you can do 1 by 5 to this side and 1 minus p accordingly, right? Or you can use the probability x equal to 5. So since it's a binomial, then I can use the 5C5 p raised to 5 1 minus p raised to 0. So 5C5 will be 1. So it will be p raised to 5 equal to 1 upon 3125. So what is the 3125 basically?
5 power 5, sir.
5 raised power 5 is the 3125, right? So you can
Yes,
do
sir.
like 1 upon 5 raised power 5, p raised power 5. So here I can say p is nothing but 1 upon 5. Okay. You can do
Sir, I
from
have a
here.
doubt
Yes.
regarding the live
Can
class.
I ask?
Last class.
So, is there any future planned session on PYQ of stats?
Not now, but we'll see where if schedule will be free. We'll ask to TH, they will take it. Okay.
Okay, sir. Thank you.
Yeah.
What question on 10.6, question 2 and 3?
Question?
10.6 is activity question number 2 and 3. Here, see for the question 2, right? See the 3x, if you know, ideally what it means is the first one, 3x equal to 27. So x supposed to be 9, right? Next case is where 5y, then 5 will be 30. So when I go for standard deviation x plus y, so square root of 9 plus 30 is what I'm thinking. I'm trying to put that way. But answer is something different.
No, that's not a correct way.
Correct. Okay. So what am I missing?
Okay. Let me tell you. Tell me one more thing. Variance of ax will be what?
It's a into variance of x.
A into variance of x or a square?
No, sir. A square.
A square
right.
variance.
A square, right?
Right.
And what
Yes,
is the
sir.
variance of x plus is something?
Variance of x, no change.
So one second.
Yes, same variance. There's no correct.
Constant is not connected.
Constant is not. Yeah.
Okay. One second. Rest of the people can we discuss it so that he will get the idea. So variance of x will be variance of x, right? There will
Correct.
not be any change to add a constant or something. Okay.
Correct.
Now,
Correct.
tell me. Okay, what about variance of, suppose I'm writing ax plus b?
It should be a squared variance of x.
Simply variance of ax or a square variance of x. So far, so good.
Correct.
Now, what question says? Question is saying variance of 3x plus 3 equal to 27. So variance of 3x plus 3 equal to 27. This is the one information. Another is variance of 5y plus 10 equal to 150. Variance of 5y plus 10 equal to 150. So question is standard deviation of x plus y. So before standard deviation of x plus y, this is nothing but square root of variance of x plus y, right? So if I will find out the variance of x plus y, I will take a square root, I will get this. So thing is that we have to find out the value of x and y. It's not you are thinking like x is 9 here. X is not 9. What is the meaning of variance of 3 plus 3 here? So can I write down variance of 3x? Yes or no?
Yes.
So this is nothing but 9 times variance of x.
Right.
Right. This is the 27. If this is 27, that means variance of x is 3.
Correct. I consider that as a 3 itself. That is 3 variants of x is what I consider that way. That's the problem. Okay. Got it.
Okay. Now, another way is, next is from here variance of 5y plus 10. I can write down this is variance of 5y. Yes or no?
Correct.
If this is variance of 5y, it will be 25 times variance of y, which is 150.
Right.
If this is 150, variance of y will be 150 divided by 25.
25, that's why it comes to this one. Okay.
So it's a 6.
Got it.
Got it? So since it's a given that x and y are independent, right? If it's independent, that means I can write down the variance of x plus y, nothing but variance of x plus variance of y.
Y. Correct.
Right?
That's
and what is the variance?
Standard deviation. Yeah.
It's
3 plus 6.
9. So standard deviation of x plus y will be square root of 9, which is 3. Is the answer? Is this answer?
Got it. Got it.
Okay. Yeah, 3 is
Sir,
answer. Yes.
Actually, I was disconnected. It was the question of a week 2 practice assignment.
Yeah. I will. One minute. I will come to that. Okay. Let's discuss this. We'll discuss it at the end. Okay. No problem.
Third one also similar case, right?
Yeah, so third one is given that what you have to do, since it says see variance of x,
X
I
and
will
Y
give
are-
you x
Yeah.
y equal to 2f. So y equal to 2x, right?
Correct.
Now, and x and g are independent. X and g are independent. It's not information about y. So variance of x is 2 and variance of g is 7. So
Correct.
question says standard deviation of x plus y plus z. So standard deviation of x plus y plus z, that means I can find out the variance of x plus y plus z. So okay. So if I will able to find out the variance of x plus y plus z, I will take the square root and I will get this value, right? So variance of x plus y plus z. Okay. So what is the variance of okay? What is the y is 2x? Yes or no? Can I replace?
Correct. It's 2
Correct?
square plus variance of x,
It's
right?
3x plus g, right?
Correct.
Since
Correct,
I know
correct.
if two variables are independent, then I can write down this variance of 3x plus variance of z.
Correct.
Can I do it or not? Right?
Yes.
So it will be 9 times of variance of x plus variance of g. And what is the
Right.
variance of x? It's a 2 and variance of
2.
g is 7. So 9 times 2 plus 7. So it's a 25. But this is the variance. This is the variance
Square
of
root.
x plus
Correct.
y plus z. So standard deviation of x plus y plus z will be what? 5.
Correct.
Right? So let's see. Yeah, 5 is the answer. Got it?
Yeah. Yeah. Thank you.
Yeah. Yeah. So Isika, okay, anybody, anything else? Isika, I will come to your point. Okay, no problem. So okay, let me stop the streaming and I will discuss the concept of Isika and we'll move. I mean, we'll start the session. Okay. Okay. If you have doubt, so you can stay here or you can go. So your choice. Okay.
Maybe topic outside of this statistics about end exam.
Sorry, can you repeat?
Yeah, yeah. See the end exam related clarification. There is some. Where will I see the calendar to discuss about it? Sorry, this is not statistics specific. End exam format. Will there be any change or is the same thing like 1 or 2? Is what I want to ask. So, will there be any separate calendar invite will be there because I don't see in the
For calendar for what? I'm not getting your question actually.
end exams. Will there be any format difference or it will be similar to quiz 1 and quiz 2?
No, it's the same quiz and quiz 2. Just syllabus will be extra. I mean, syllabus will be from 1 to 12.
Correct. Okay.
But
Sure.
major portion will be from 9 to 12. Okay. And some portion from 5 to 8, or let's say some questions from 5 to 8, some questions from 1 to 4. But major portion will be covered from the 9 to 12. As in quiz 2, major portion was from 5 to 8, right? Some questions from 1 to 4. Same thing. Okay.
Okay.
Yeah.
Sir, what will happen after end-term exam?
Whether you will pass or it's up. Okay. And after that, if you pass the exam, accordingly you have to choose the courses of the second sem. Okay. Okay. So.
So can I leave this meeting? I have no doubt.
Yeah. No problem. Those who have not doubt, anybody, you can leave. Isika have doubt. So
which concept are you going to explain?
Isika have doubt some concept from week 2. So what I will do, I will stop the streaming now and we'll discuss the Isika doubt and we'll close there. Because I think you got the concept of week 11 and 12, right? We have discussed the distribution, some questions or everything. Okay.